Good afternoon, guys. My name is Siddharth Saxena, and I am a user experience architect in Primary Data. So after all that cool technology that David just described, I think you guys might wake up by seeing our user interface. So what I'm going to show you today is a little UX preview of a couple of use cases, how we are going to deal with them inside our product. So I'm going to walk you through these two use cases, which are almost real-life use cases that administrators deal on a day-to-day basis. But before I start on that, I want to point out one thing, that with all this, the technology that we are building into data virtualization, a counterpart in the user interface world is data visualization. Because unless you can visualize what you are trying to control through automation, you cannot manage all of that. So that's one of the big focus when we started on designing a UI on how we can really show this data into a user interface. So what you're looking at over here is a list of all the virtual shares that the administrator has created. Now, this particular administrator has these 6 shares that are getting a bunch of data from these applications. Some are Oracle applications, some are Oracle applications running on VMware. And in third column, you can see that there is a concept called application profile associated with each of these data shares. These application profiles are nothing but your policies that are diverting the data into the right data stores. Now, some of these applications, as you are seeing, has really good compliance, which is basically showing you that the data is moved as per the policies that you have set. Let's say a call comes into the administrator, and the Oracle admin is telling me that the business needs have changed, and now they want to increase the load on the Oracle database. So how would I deal with that kind of a scenario? In order to increase performance, I would go into the detail of the share. In this case, an example is I'll go into the Oracle DB warehouse application data share and look into the detail of what's going on inside the share. Now, as you'll notice on top, we have a really nice area that's showing you a bunch of metrics that is giving you additional information about what's going on in this share. The compliance rate, as you can see, is 98%, which basically just means that the policies that the administrator has set up are actually doing their job. Their data is placing itself into the right storage containers as the administrator has defined. On the right side, you'll see that the latency has just started going up because the Oracle administrator has increased the load. So how would I start fixing the scenario of trying to reduce latency? By the way, you'll notice in the middle of the screen that we also provide a really nice way to show snapshots, where the admin is looking at a timeline view of your snapshots in history, and you can really easily go and select if you have to restore using one of these snapshots. In the middle of the page, where it shows application profile, the Oracle T2 policy that has been applied is guiding how the data is coming in. So if I have to increase my performance, let's see what the rules are inside this policy. So I click on that, and here I'm seeing the details of my policy, where the 3 directories, data, archives, and logs from the Oracle database have a bunch of service level objectives defined on them. There are some performance rules, there are some availability rules and security rules. And in order to increase performance, I can choose from a bunch of available application profiles on the left side. So the Oracle T1 appears to be one of the profiles that is probably on a higher tier. Also, by the way, we are showing some relative dollar value so that it helps administrators in taking a value-based decision. If I click on Oracle T1, it shows me that the associated storages with this particular profile will provide a latency of less than 2 milliseconds. And of course, the cost is going to be really cheap for me, 14 bucks extra per month. So I'm happy with this one, and I hit apply. And you'll notice that the compliance has gone down, which basically means that the system is doing its job and the files are about to be moved. And as the files start moving, this compliance rate is slowly going to improve, and after some period of time, it will again, as per the policy, reach full compliance. And you'll also notice that the latency has gone down from the earlier 3.6.
Okay, so granularity is at the file level for everything?
Yes.
Okay.
The objectives are placed on the files via the application profile that gives the pattern for understanding what the function of the different files are.
Okay, and if I want some performance level between flash and disk, then I give you a hybrid backend to throw the stuff on.
Yeah, yeah.
So this product is basically giving you really a single pane of glass view into your entire data. Some small and medium businesses may use this product directly, but larger enterprises may plug it into products like Enterprise Manager or VMware's vCenter. So this is the end of the first use case. Now I'll go into another use case which is also fairly common. Imagine a scenario where administrator is trying to provision a new application, and for that they need a bunch of more storage. Now the choice in front of them is either they purchase additional storage or they try to free up storage in some way. So let's say I receive an alert which is telling me that I'm running out of capacity on some of my third-party data stores. I go into this particular view, which, by the way, is a really fantastic view of your entire storage infrastructure into a heat map kind of a view. So all the pink elements that you are seeing are really hot files. Orange is medium hot, and blue is cold file. And the gray portion
is each horizontal stripe a storage pool?
Yes. Each individual line is a single data store.
Targeted store?
Yes.
Okay. So if I'm defining a policy is a group of stores that I have pre-configured to meet my requirements?
The word policy is overloaded and ambiguous, so we're trying to not use it in our vernacular. What we're talking about is putting service level objectives on the data objects as per a pattern that goes with the application. That is, the application profile ends up defining the objectives on the individual files. Those objectives get automatically mapped to the capabilities of the storage system.
That I've told you, or that
it actually infers from watching the performance, and that may actually change over time.
Okay, but
some of the capabilities have to be defined, levels of reliability, etc.
Okay.
But some of them, like the performance that they're able to supply, is determined dynamically. And here's another very important point. It's determined on a per client that accesses it, because you may have differences in the network
bottleneck between client A and storage device
Consider
J.
that you have to do that for direct attached media, so that it understands the difference from a local client accessing that media and a foreign client. So the performance is really a function of the pair, the DS, and the client accessing it. So it'll make...
Okay, and so I'm going to say this is my high performance tier, and my goal on it is this, but at some point when load forces performance to fall below that minimum, you can start taking action.
Yeah, and the system will actually endeavor to protect the system from degrading by not letting it get overloaded, and evict objects that are consuming performance up to the threshold to where it can service the other ones. So it's actually looking at load on the different
And it'll do that by load balancing across equivalent pools, and then if that fails, shoving lower priority stuff down.
And the fundamental way that is behaving is by actually doing an economic simulation and having each object look at its enlightened self-interest about where it should go, and the storage systems act like LAN boards that are setting prices on their performance and capacity to attract or dissuade the objects that use them. So it actually works out very cool internally.
All right, so
I just wish it would scale down.
Scale down?
Yeah, there's clearly it's just like there's a minimum size it's going to work at, and that's beyond my budget.
So, as an administrator, when I
use direct attached means you could use it on yeah.
Yeah.
So when I'm looking at this picture in the medium tier, if I really want to use that tier for my applications, I look at one of my data stores. I can really free up some cold data from there. But of course, I don't want to make a one-off decision. It's a policy-based automated system. So I want to drill down into this data store and see what's really going on. I click over there, and again, I really get a really nice view of some more detailed information about this particular data store. It shows some of the metrics up on top. But in the middle area, it's showing all the shares that are diverting the data traffic onto this data store. You'll notice the first two shares are using the application profile Oracle T1. So as an admin, I want to drill down into that and see if I can make any change to my service level objectives. Again, here in the last column, there is a particular rule set for offsite data migration that says that all my archives move them to a colder tier when the age is more than 6 months. As an admin, I may be fine with moving even 4-month-old data. So I go and edit that particular profile and change it to 3 months instead of 6 months, which actually will reduce my cost. And then when I hit apply, after some time, the data will move away from the medium tier down to a cloud tier. So this was...
So we're looking at a simulation here. This is not real, right?
Yes, this is a UX preview that we are giving you. So at the end, I come back to my list of virtual shares. Any other questions?
Now, in the prior scenario, you actually were signifying the migration of data to a faster tier. Is that what you did there? Is that
raised the objective to get the data onto a faster tier to improve the application performance.
So you raised the objective, and behind the scenes, it moved the data.
That's right. And this other example is where objectives were having a hard time being met because you didn't have enough resources. So he found some things that could be demoted where you could loosen the objective. Here, in this case, allowing it to get archived off to a slower tier to get it off of your online tiers. Because that's really the two functions that you do, is change the objective to make it higher to increase the performance, or find things where you can lower the objectives to allow them to migrate the other way.
It becomes kind of backhanded QoS.
Can you model it then to say that, for instance, you can see that you need a certain type of performance, and therefore the stuff that needs to be put in needs to be of this quality, so you know what to buy as the next chunk of things?
There's some very interesting things you can do once you virtualize the data and have it instrumented to be able to see these things. You can actually do capacity planning that'll tell you what you will get the most value in adding, what type of storage system would give you the resources to best suit your needs and be the most beneficial economically. We could see even modeling the time to having a positive return. What's the payoff time?
Yeah. So one of the things that we did a call last week, as obviously you probably remember, and one of the things when I came off the call, I thought, I can't see why you do this if you think of it as a traditional model where people have virtualized before and they've used this excuse of, I've got lots of different pieces of storage and it allows me to consolidate or migrate off them, and that seemed like, well, why would you be reinventing that? What you've actually just said there is you've got the ability now to broker what you want to buy and add to your pool of capacity.
Yeah,
whether that's cloud, whether that's a physical box, whether that's a vendor's product, whatever it happens to be.
It's a bigger idea than
so you
get
can
best use of the stuff I have.
Now choose
Do we have
things
time that I
much
can
better.
ask a question? Because I want to get feedback on something, if we have time or not. It won't take too long.
We're about to make time. Thank you, Siddharth, for giving us a preview of the UI.
So,
all right, here we go. We're back here, David.
one of the
Yeah, David, we've already had tweets saying we should just get 4 hours of you. So,
so the question I have is around backup and the whole concept of backup going away. We already know that we went from tape kind of backup to disk backup, and that backup is moving towards kind of a cloud archival model. The thing about backups is you're fundamentally moving the data to a new namespace, to a new protocol and everything, and it takes a lot of work to re-import that data to go find the same thing you're talking about. Again, it has to do with continuity of the identity of the data. When you have to go hunt through your archive tapes or through some other place to find that thing, it's very, very difficult. So what we've theorized is the ability to change the whole notion of what a backup is by making, I guess you could say it's related to or similar to SnapVault, where you make a snapshot in the namespace, change the objective on the snapshot to where the objective states, my objective with this is to make sure that it's protected on different storage systems where it can be recovered even if the rest of the world blew up. And that objective causes the data to migrate to another data center, to a cloud tier, out into object-based storage. But because it's a snapshot, and the way the system works is if you start accessing the data, it'll pull it back online and give you access to it even in place. So you can take that snapshot and comb through it and read it, and it'll pull the pieces in as needed as you read them. Or you can clone that snap back into the main namespace and then actually start interacting with it again. In other words, the backup isn't a separate namespace. The backup is a snapshot within your primary namespace.
The backup doesn't have to be a separate namespace. First and absolutely foremost, it has to be an independent copy.
Storage system, yeah.
Independent to tactical nuclear weapons.
Copies.
Yeah.
Right.
Multiple
Well,
copies.
I'm saying I'm thinking of a backup copy, but the second problem is it's got to be cataloged.
Yeah.
And it's got to be cataloged.
I'm glad you mentioned that.
And it's got to be cataloged much deeper
Yep.
than you guys are currently operating.
So
because if this is a VMDK of a Windows virtual machine that is a file server, somebody in accounting is going to call and say, we don't even remember the name of the spreadsheet that the woman who quit last week who does the end of quarter close used to use, but you, backup administrator, have to find it for us.
And it's in a VM.
It is a XLS stored inside a VMDK.
And you don't even know the name of the machine.
And I know roughly what folder it's in and roughly what date it was used, and I got to be able to do a database search to figure out what file they're talking about.
So maybe not to that level, but let me start. Nobody's asked this question, but I'm sure it's occurred to some of you. If you pull out all the metadata, if that gets lost, the data becomes useless.
The question was just asked on Twitter, so got to give.
All right. Somebody credit. Yeah. All right.
Yes.
So there are,
and that frankly was a bigger reason of why people didn't buy Acopia.
Yeah.
Because it was a roach motel. Once you put your files in, you could never get them out.
So in addition to having multiple levels of protection within the metadata service, the fail-safe, the third backup parachute, is the fact that the system periodically places copies of the metadata into the storage containers themselves so that they're self-describing. So if you had a nuclear bomb go off and all you found was this one lone storage container, you could go through it and reconstruct the files that are on it.
Unfortunately, it's probably half of the files that were in the logical folder that it used to be. It's you do need to spit it out.
That's particularly important for the cloud.
Yeah, but you need to spit the data out of the namespace and store it on the new copy physically in its logical organization, so that if your metadata server went away and you went away,
yes,
then I could recover the data.
That's exactly what I'm talking about. We embed a file here that is interpretable by utilities outside us.
Right.
It can take the data that's on that container and put it back together to a full representation of metadata embedded with data. So without us involved, can reconstruct the metadata around the data that's sitting there.
There's got to be an
That's particularly important for cloud because the whole point of that is to make it self-standing.
So but when you're taking these snapshots, you're doing this potential backup, this SnapVault type scenario, which I personally hated SnapVault in all the years I worked at NetApp, and anyone who ever used it. But that aside,
That's why I'm asking
That-
you, what are the problems
that
with,
aside,
with the paradigm?
who is the broker handler for performing all these activities? So you're saying before, you're saying when you do a snapshot, we're going to use the underlying snapshot capability. And if it sucks, you get to inherit that suck. And and if you're transferring to something else. So if we talk just pure backup, are you the broker, or do we have something else that is the handler?
So the
Because we only back up to restore. Backup means nothing.
No, we
it's
back
restoration.
Up to, we
that
back
is
up
the
to
key.
recover.
To restore, recover.
Well, no. Restore to me means we copy the data back. And
pull the data back.
I want to access it from the backup store right away. I want to recover.
We back up to recover. That's the only function.
right. The difference between restore and recover goes away a lot when it's still sitting in the same namespace.
Yes, which
There is no real
I
difference.
like.
There is
Yeah.
no real difference
Yeah.
at that point.
But that's why I ask, who's the handler that's managing that part of it? Because
So the metadata service understands where files are located and whether they're offline or online, and it's responsible for the migration of files between the different storage containers, pulling them online, pushing them offline.
And does it
So-
dynamically spin up as many data mover
Correct.
proxies as I need? when I need
theoretically,
them?
you could
And a
spin
question-
data offline to tape.
And the question from
That's
Twitter
exactly right.
is-
We could do that.
Yeah, well, especially with like a
a
spectral
question
black
from
pearl.
Twitter. It seems like we're all the same line of questioning. Is what happens when that metadata store is corrupted?
If the metadata store itself has a number of levels of protection, the high availability for being online,
When it gets
and
corrupted, though.
replication.
I said before, it's like this thing is uncorruptible. So when it gets
Everything-
corrupted,
so when it
because
gets corrupted-
I have to go repair those at times. When it happens.
Right.
What's our recourse?
So the recourse is the fact that it's periodically making snapshots of itself in case it wets its own pants.
That's its
right.
transparent self-healing capability.
Yeah. And it's making those snapshots in a way that allows the data stores to be self-describing so that they can operate independently if needs be. So those are critical questions, because when you separate the metadata from data, now you have to have the two before you really get any of the benefit.